So these are Lewis structures. So this is with the covalent bonds, all right? So our molecular compounds or molecules, as opposed to what we did for ionic. Remember, ionic was the one where we showed the transfer, and then you ended with little brackets, and then that was your answer, right? I showed, you guys had to show me the whole electron transfer. So this is not that. That is how we deal with metals bonding with a nonmetal, okay? So Lewis structures is going to be when we have two nonmetals, and we now have to form these little funny shapes. So this chapter, we're not going to worry about the funny shapes. We'll save that for after this next test coming up. But you are going to be responsible for drawing them. Some people have learned in the past how to make these, and usually the teachers describe it as connecting the dots. I don't want you connecting dots. Okay, so if that is you, just please open your mind to the new way. I need you to do it my way because I promise there's a reason I make you guys do it. Okay, so what we're going to do is, it's called needed, available, shared. Okay, or NAS. Okay, so, and we'll run through what each of these mean. We're not going to spend too much time writing all these details because honestly, I could sit here and talk at you, but it's not going to make sense until we start doing a bunch of examples. So we want more examples so that homework is easier tonight, okay? So N stands for needed. Okay. Now needed is like the goal. Okay? Meaning most of our elements up on that periodic table, what is their ultimate goal for valence electrons?
To make 8.
To have 8, right? So for this, your answer, if I'm ever asking, okay, how many are needed, it's 8. It is 8 for each element. Unless, I know, dun dun dun. Unless you have hydrogen. Hydrogen only needs 2. He's on the 1s sublevel, so he can only fit 2. Okay? Beryllium, you guys don't use this one too often, but that one's a 4. And boron is a 6. Now, it might bother some of you guys that we're dealing with beryllium and boron. Aluminum's going to bother you too. You will be drawing a couple covalent compounds with those. Once again, it's that shade of gray there, right? Where it's kind of that blurred line between ionic and polar covalent stuff, okay? So just know that if those pop up on any of the questions, use the 2, 4, 6. Otherwise, no matter what, you guys are telling me 8, okay? All right. A stands for available. I probably should not have wrote this in purple. That's okay. Okay, so available. What do you guys think available is talking about?
How many are there?
Right, so how many are there? So valence electrons. It's going to be valence electrons, okay? And most of you guys have gotten pretty comfortable with finding your valence electrons. You're going to pay attention to what group they're in, what column they're in, okay, to get your little valence electrons there. All right, if you notice, it is just a subtraction going on to figure out shared. So this is talking about how many these atoms that are getting bonded together in a molecule, how many electrons are being shared. They get shared in a what? Bond. Yeah. Okay, so they get shared in a bond. So what we do is we take that number, and every bond has 2 electrons. So we're going to divide it by 2 to figure out the number of bonds. This right here is why I make you guys do a NAS, because it's going to help you find your double and triple bonds when it doesn't seem overly obvious. Okay? So, the only last thing I want you to do, let's write it 2 side notes real quick. All right, so next to this bonds, I want you to say 1 bond is equal to 2 electrons. Now, that might be common sense for some, but some of you guys are going to need that little reminder in a second. Okay, 1 bond only has 2 electrons. Okay, we're talking about like the actual thing that is connecting them. It's the fact that those orbitals are overlapping each other, so 2 things are getting shared, 2 electrons. All right. The only other thing I want you to add to this little list is put a bunch of stars next to available because that is the most important number on here. We're going to have to come back to the available at the very end of every single drawing to make sure that that is how many you have. This is also how we deal with the weirdo ones where we have expanded octets, but y'all don't have to worry about that yet. So I'm just going to kind of push this off to the side. So let's start with the first example. Let's go simple. Let's just start with dioxide or diatomic oxygen. Okay? So for this one, we have needed, available, shared. What my students in the past have done is they'll put the actual elements that are listed, they'll just list them all out across, and then that way they know what numbers go below them. All right, so this is just an oxygen and an oxygen. You see that? So for needed, how many does the first oxygen need? 8. Good. How many does the second oxygen need? 8. Add them together. What do we get? 16. So remember, for the needed line, usually it's 8 unless you're dealing with one of those exceptions. That's where those numbers came from. All right, available. So available is the valence electrons. Each of your oxygens have how many valence electrons? 6. They're in group 16. So you have 6 for this one. We have 6 available for that one. So total, we have 12. What are we doing with those two numbers?
Subtracting them.
We're subtracting them to get 4 electrons that need to get shared. So we divide it by 2 in order to find 2 bonds. So this right here is going to show you a double bond automatically. Okay? So now that we have this information ready to go, we're just going to draw our 2 oxygens next to each other. We're going to give it a double bond, meaning 2 lines. And now we have to fill in the rest of the electrons. Because, remember, what is the most important number?
6.
12. Remember, the one that we drew all the stars next to. All right. So we're gonna go, and we have to make sure we show all those, okay? So each of the bonds has how many electrons? 2. So we have 2, 4, 6, 8, 10, 12. Okay? And now you're done. Questions? Okay, so we have, let's do CH4, because that works with one of the exception ones, okay? So methane. All right, so for needed, available, shared. Needed, how many does the, sorry, this is what they would do. They would just list them all out like that, so they can write their numbers below it. So carbon needs how many? 8. Hydrogen? 2. This hydrogen? 2, 2, 2. Okay, so we have 2, 4, 6, 8. 8 plus 8 is what?
16.
Good. Okay, available. Carbon has how many available? 4. 4 was right. Each hydrogen has how many?
1.
Okay. So that would give us 8 total. So 16 minus 8 is 8. Divided by 2 is 4. Now this one is a really obvious one to draw, and it's probably going to frustrate some of y'all that we just did that whole math thing for it. But you would put carbon in the middle. Okay? Whenever, and that's a rule. If you ever have carbon available, put them in the middle. Carbon likes to be in the middle. He has the most bonding sites available. Okay? So we put carbon in the middle. And we need to have 4 bonds going around carbon.
Oh.
And now we're going to add in the other letters to it. Okay? But our most important number on here is this 8. We got to make sure that there are 8 electrons in this picture. Are there 8 electrons in this picture? Yes. 1, 2, 3, 4, 5, 6, 7, 8. Okay? You see that? Okay. Let's do another example. Are you ready for another one? Carbon dioxide. Do it. Carbon dioxide. So if you're working through NAS, you would put carbon, oxygen, oxygen, and start doing your little calculation thing there. So give it a try, and then we'll check it together. All right, so for the needed line, how many did the carbon need? 8, and each oxygen? 8 and 8. Okay, so we had 8 times 3, which is like 24-ish. Yeah. All right, available carbon has 4. Oxygen, 6. This oxygen was 6, so we had 16. So subtracting those, we get 8 divided by 2 tells us 4 bonds. So, just like the last one, I told you carbon goes in the middle. So you put carbon here, and you have to have 4 bonds coming out of it. But how many other things are actually getting attached to it? Only 2, right? We only have an oxygen here and an oxygen here. So what do we do?
Dots.
Double bonds. Yeah, good. This is why NAS is nice, because it will tell you on those little instances when you have a double bond or a triple bond. Okay? All right, but we're not done yet. We got to go back to the 16. Okay? And so we get 1, 2, 3, 4, 5, 6, 7, 8. So I'm at 8 so far. We need to have 16. So 10, 12, 14, 16. And that's what carbon dioxide looks like. Yes.